Assalamualaikum and greetings to all. We are from Group 6, SEEE 3533. We'll be presenting on our case study of Mission Pop. I will introduce our team members. The first one is Idlan Harith, and the second one is me, myself, Novika, and the third one is Nur Sabrina. The first one is modulation. What is modulation? Modulation is a process of varying one or more properties of a periodic waveform, which are the carrier signal that contain higher frequency than the modulating signal to modulate the information, and the modulating signal that contain all the information that needs to be transported. First one is amplitude modulation. Amplitude modulation is the change of the carrier signal amplitude according to the modulating signal. This is the illustration of amplitude modulating signal. The first one is the message signal, and then second illustration is the carrier signal. Then the third one is the amplitude modulating signal. The example of amplitude modulation is the radio and walkie-talkie. The next one is the angle modulation. The angle modulation is a modulation in which the angle of the carrier wave is varied according to the baseband signal. We can encode information as either time varying phase (PM) and time varying frequency (FM). This is the illustration of FM and PM wave. The next one is frequency modulation. In FM frequency, it is very linear in this equation. And then the term of represent the frequency of the unmodulated carrier, and the constant represent the frequency sensitivity of the modulator. This is the illustration of frequency modulation FM. For the phase modulation, PM is the form of angle modulation in which the angle is varied linearly with the message signal MT, as shown by theta t equals to 2 pi fct plus kpmt. The term of 2 pi fct represents the angle of the unmodulated carrier, and the constant kp represents the phase sensitivity of the modulator. This is the illustration of phase modulation PM. For the relationship between FM and PM, the phase modulation of MT can be differentiate frequency can be represent of the differentiate frequency modulation of MT. For the frequency modulation of MT, it can represent by integrate phase modulation of MU DU. This is the illustration of frequency modulator and phase modulator.
Hi, my name is Len. So next, I will explain about radio digital modulation. So, what is radio digital modulation? As we know, is it transmitted through the free space if the analog carrier signal is used, and the technique is similar to the analog modulation. So, in radio digital modulation, we have three types of shift keying. Okay, the first one is ASK, which is the amplitude shift keying. Second one is frequency shift keying, and the last one is phase shift keying. Okay, the first one is the amplitude shift keying, ASK. ASK is a technique which carrier signal is the analog and data is the modulated digital. You can see from the picture there. The binary signal when modulated give a zero value, and the second one is frequency shift keying. So frequency shift keying is an analog carrier signal is modified to reflect binary from the amplitude shift keying, ASK. And the last one is phase shift keying, PSK. PSK is the modulation process where the phase of carrier signal is changed by the varying the sine and cosine input at a particular time. So here is a formula for phase gain is bandwidth PSK equals to frequency base equals to 2 FM. Okay, here the picture of the phase gain transmitter, that we use a multiplier here. And next is we use for receiver. We also use the multiplier here, and we have the probability of error. And this is the formula is P equals to 1 over 2 ERFC in bracket square root EB over NO, and where the EB is a EC squared T over 2. And the last part from me is a binary phase shift keying. So binary phase shift keying is a BPSK, and we know as a two-phase PSK or phase reversal keying. where a sound wave carry take two phase reversal.
Assalamualaikum and hi, I'm Sabrina. I will be continuing our presentation with quadrature phase shift keying, or we call as quadrature amplitude modulation QAM. So what is QPSK? QPSK is where the sine wave carrier takes four phase reversals from 0 degree to 360 degree. For example, 0, 90, 180, 270. It will transmit 2 bits per symbol or signals, i.e. 00, 01, 10, and 11. It is possible due to the fact that they are not limited to two states and it varies in terms of phase. Note that receiver need to extract the original information from modulated signal and maximum separation between four phase is done to be easy to distinguish the state. So we will add more bits on one single segment and the bit stream can be parallelized, so every two incoming bits can be split up and phase shift keying a carrier frequency. Therefore, this is, as you can see, the mapping of QPSK signal using gray code and the equation as A cos omega ct plus 2m minus 1 times pi over 4. Next, moving on to quadrature phase shift keying transmitter, we are having the block diagram. We have a bandpass filter to reduce the unwanted signal, which is we take BPSKI, which is I is in phase, and BPSKQ, Q is quadrature, to have our QPSK. And both signals will be demodulated with oscillator cos omega ct and sin omega ct. And we use serial to parallel converter to transform one binary series into two series where logic 1 is positive 1 volt and logic 0 is negative 1 volt. So this is the waveform and channel I and channel Q. So next, moving forward, this is the constellation diagram that used for our quadrature phase shift keying. PPSKI plus PPSKQ equal to QPSK. That's why in the gray code we have 1, 1, 45 degree, 0, 1, 135 degree, 0, 0, 225, and 10315. Then next, moving on to the receiver. The equation almost the same like BPSK just now for the probability of error, and this is how the receiver looks like, where we have bypass filter as well to reduce the unwanted signal, and both signal will be demodulated with oscillator, but we have additional low pass filter to filter out high frequency signal after the demodulation process, and output from the comparator is logic 1 if positive value and logic 0 if it's negative. And the binary will produce by using parallel to serial converter. Then we have the equation, right, for C over N is actually our bit error rate. So this equation shows that bandwidth is FB, where FB is the bit rate, and EB over N not equal to C over N. And our BW is bandwidth, and our N small here is actually the efficiency. So moving forward, we will be having analog versus digital. This is how the analog communication system, which the data will be transferred with the help of analog signal, and this is the digital communication system, where the digital signal is used for communication in between source and destination. Lastly, we have digital to analog conversion aspect. The unit is baud, and the symbol is the final representation of signal before signal is transmitted through physical medium. So baud rate is number of symbol transmitted per second in S, and bit rate is number of bits transmitted per second in B. That's all from our group. Thank you for watching.